Well, the lesson was about constructing a flow map using the rules of factoring polynomials. So they had a list of words such as trinomial, polynomial, those kinds of words, and they had to put them in order where they flowed, and they could correctly factor any problem based on their.
Do y'all know what a flow map is? So I'm going to give you just a brief example of what it might look like with just a real life type of explanation, but then you're going to apply that to the factoring that we learned before break. Okay? So for example, you go to Fuddruckers. Now I'm going to make you want Fuddruckers. Alright? You got some choices when you get there. You can get chicken. You can get a burger. Or you can get, so basically you start out with one main thing and then you can have a couple of different choices. Well, once you get those choices, then there's more choices for each of those choices, right? All right, you got your chicken sandwich. You might want lettuce and tomato and cheese. Or you might want mayonnaise and pickles. Started out with a big choice. Then there's 3 smaller choices. Then each of those had some choices. That's an example of like a flow map. It's going to go one step to the next. Okay? So what I'm going to do is I'm going to give you some cards, and you're going to use the following words. All right? And these are in no particular order. That's part of your task. You're going to put them in the order that they need to go in, and they will make sense when you create your flow map. All right? Perfect square trinomial. So you go ahead and be thinking about how these will go together. So I have 9 index cards for you. You're going to write these 9 words on those index cards, and then you're going to move them around until you get a flow map that makes sense. Once you get your flow map, remember we had Fuddruckers and we went to chicken, burgers, and salad. Each of those lines needs to have an explanation about why would they hook together. Chicken is a type of food that we could have selected off the menu at Fuddruckers and make it a complete sentence. Okay? So same thing. Say trinomials and the difference of 2 squares went together. If that was the case, you would have to tell me how they went together and write a sentence about it. Step 1. Your group needs to write the 9 terms, and then as a group, you'll put them in order. When you think you have them in a correct order, me or Miss T can come by and do a check, make sure you're on the right track, and once you have that, I'll give you the big paper where you can put them on there, and then you can write the sentences on the lines that connect them. Okay? Questions? Go ahead and get started.
An organizing aspect of writing step by step what to do if there are more than one choice to begin with. So starting at step 1, and then you have these choices, and then those choices have choices, and so on until you get a final product. So it is just an organizer that shows the step-by-step process. Okay. Well, I like the concept map idea, but for factoring polynomials, there's not a whole lot of vocabulary to tie all the different pieces together, but it is important about which rule you use and when you use it. So I thought, yes, they could still use bits and pieces of the concept map, which is, making your connection and writing a sentence to explain why it connects. I think that part was important, but also we needed the importance of the order, which the flow map did that. So it was kind of combining the two together and using that concept map strategy, but with a purpose of order. I think during that lesson they actually did work good as a team and talking it out because, like I said, there was multiple ways they could have set it up. So, they did get a little competitive with I think it should go this way and I think it should go this way. And technically, maybe they were both right, but kind of justifying their ideas of why they thought it was right. I think was a big
And
one.
then regrouping, okay. So over here, and then
the factoring, you
Here.
put GCF under the factoring. And then you put the multiply and add method under that. Chill.
And then. Okay. Different. GC. No. Wait.
I need some more notebooks.
And then would it be this? Because if you don't have GCF, you do this.
Yeah, so put.
And then
I'm just confused
These
myself.
go together.
regrouping.
Wait, no, these go together, and those go together. See, because you can get a difference of 2 squares from binomials.
But which one would it go under? Factoring would go under here, but this would go under here. No, it'd be this.
What's the X and add method? I mean,
It's where you do where you have to multiply, get this, and add to get this.
like,
If you were trying
oh
to
yeah,
get
okay,
18,
that would be with the trinomial.
oh, so it'd be like this with trinomial, so it'd be like over here. No, but it isn't under here.
I swear, that goes right there.
No, it does go under this. Because you either get this one or this one. No, because, no.
Yes,
No,
yes.
you have to have 4 parts to do this. No, you have to have 3 parts, never mind.
Because you have the 3 and then you multiply those together, and that's your multiply,
And then you
add
get
the middle.
And then you get a
I'm confused.
polynomial.
What did you do? What?
Because after you do the multiply and add method, you get a
Why'd you do
polynomial.
that?
Yeah.
This is at the top.
Yeah. And then no, it's not.
So you could do factoring and then some kind of polynomial thing because after you do the multiply and add method, you don't have a trinomial anymore. You have a polynomial
Yeah.
because you regroup them.
So this is the end. There's the end of that one, right? I don't know what we're doing here.
I could have sworn polynomials was all this stuff. Miss Davis. We need.
We know that this goes with that, and this goes with that, and that goes with that.
And that is under that. And that's under that too.
Okay, so we group these 3 together?
And these two.
And those 2?
Yeah.
We don't really know where this goes.
Where does regrouping go?
Under here, I thought. No.
When do
But
you-
it would be
when
with
do
the
you regroup?
trinomials.
Yeah, because it'd be like that. It would come under the
So
X
put
and
that
add.
right there and then those over here
I
and then
thought
those
it'd be
over there.
like. No, that's not right.
So it'd be that, the GCF, and then you could get binomials, right? Or trinomial, right? And then those 2, and then the Greek. Where does the polynomial?
Right here?
No. What's a polynomial? What's the definition?
It's 5 or no 4
more.
4 more.
Is it 4 or more? So it would go right here.
Maybe here?
You tell me.
I don't know.
There. Is that right?
Could be. Can you explain how that would work?
I thought you said you checked it.
Yeah, because after you do this part, it turns into that.
And then you have to regroup them, and then you work them out.
Okay,
And then you factor them out.
So it's go like this. No.
No, not like that, because you have a polynomial, and then you regroup them.
Yeah.
that could work.
So can we do it now?
You got your explanation ready though? Yeah. You know why that goes with that?
Because after you do the
that,
X and
after you do all
add
the
method,
stuff,
you
it
have a
turns into 4 parts.
polynomial.
It turns into the 4 parts, and that
You
is
split it
a
up.
polynomial.
And then you regroup the polynomials, and you factor them
And then
out.
you get a binomial after you do. Never mind. Just don't listen to me.
How do you get a binomial from a GCF?
Because remember, if it's 2 parts, you go how?
Connected to the GCF.
You have to get a GCF to get a binomial, or you can, I don't know.
When do you take a GCF?
Would that be trinomial?
When you don't have
At the
any.
beginning of each problem, right? Does it matter whether it's a binomial or a trinomial or anything? No. Yes, GCF.
Okay. We're good.
This is.
The big paper.
I may have to go get some more paper, but use what you need, and then give me back the rest.
Do you want us to glue these on there?
Yeah, we'll go.
If we took a polynomial afterwards and used their flow map and only did the steps in their flow map, you could get a final answer based on how they had set up their flow map. I think it went as planned as far as what I had planned and what was accomplished. There are a few pieces I would change about it. For example, I chose to do a real-world example that did not have anything to do with math, just to show them the idea of a flow map. And I think it was just too far-fetched and spent a little too much time not on a math example. I think we could have maybe done that with order of operation rules that they already knew, or something still math related, not necessarily that topic, but to show them how flow maps can work in math. I feel like it went well. There were bits and pieces, but overall, each group constructed a flow map on their own that did flow correctly and did illustrate how to factor polynomials. So I feel like the objective was successful. There were bits and pieces that could be improved, but overall it was a success. You just have to try them multiple times and really take them one step at a time. Maybe start with a little concept map on a small topic or something they already know, and then work your way to these other kinds of concept maps, and just really stressing the importance of the pieces. Okay, we can't just put them together. We have to explain why they go together, and I think that's what makes the strategies work. Not making an organizer. We all know how to make organizers, but the why behind it. And so breaking it into little pieces at first and introducing them, introducing the dialogue strategies first so they are comfortable talking. So when you get to these bigger projects like the concept map, flow maps, that kind of thing, they know how to talk and discuss appropriately, and you know, everybody's not just sitting there waiting on something to happen, they're actually talking.